Hello, good morning, everyone, and thank you all for joining today's webinar. And it's been an amazing program for all of us. And we all know that we have coded a lot, we have learned a lot through these sessions. And to let you know, this is going to be our last week of these sessions, these beautiful sessions delivered by industry experts. So, talking about today's session, it's going to be delivered by Sheshanth. So, talking a bit about Sheshanth, like just like going to the topic a bit. So it's going to be getting started with deep learning. So it's going to be about my favorite topic. I also love machine learning, deep learning. So today we have a speaker who's going to speak about deep learning right from basics. Okay, because even if you don't know anything, you're going to get a lot of insights today. So make sure you put on your headphones and you get learning. Okay, so talking about the speaker, Shishant is currently working with Cerner Corporation as an associate senior software engineer. So he has overall 4.8 plus years of IT experience, armed with a passion to solve real world business challenges using data analytics. He's also proficient in building and deploying complex machine learning and deep learning models. He's also skilled in Python, Java, SQL, data science with a postgraduate diploma focused in machine learning and artificial intelligence from International Institute of Information Technology, Bangalore. So today's speaker is quite knowledgeable. He has a lot of knowledge. He has worked in deep learning sector, and he's going to take up this webinar today. And he's here with us in the stream. So let me just add him to the stream and make him interact with all of you. So hello Shishant, thank you for
Yeah.
joining and very good morning to you.
Hey, good morning, Omkar. Yeah, am I audible?
Yes, you are.
Okay. Okay, so very good morning to you all. So I think we can get started. I think Omkar has already introduced myself to you guys. So what I have been working on and all the things that I have been doing with my current organization, right? So it has been a really tremendous journey, how I did even land into this data science profile and everything, right? So before we getting into the some of the talking about some of the industrial concepts and then talking about some of the how these deep learning models are being used in the industry and everything, right? So let me just tell you a little bit of a story about myself, right? So as you all know, right, so I've been working with Sana Healthcare Solutions, and most of them who are trying to make up their career in terms of data science, right? So mostly they'll be having this misconception saying that I know if you're not from a technical background or if you're not from a CS background, so they won't be able to do that. And then if you could look a little bit about my background, so I have a completely different background altogether. Right, so I started off my journey in a startup company, working on embedded systems. So that was a little bit about me. Right, so I worked around some 1 year 2 months in that startup company, and then I switched to Sana Healthcare Solutions. And at Cerner, I joined Cerner as an MFC developer. So most of you guys might not be knowing what is exactly is MFC. So MFC is nothing but your Microsoft Foundations class, right? So whatever the Windows solutions that you look at, so that's all built on top of MFCs. It's complicated with respect to pointers and everything. Right, so I started off my journey more often, you can say, around C++, and then I built some really great interest on data science and how the data can try to solve so much of problems. And back in 2018, I built some really good interest, and then tried to take up a course, and then I got a beautiful internal transition over there to work in deep learning, and then I got lots of motivations and things to do work on these things, right? So I've also built a lot of applications within Cerner, right? So talking about different debugging tools or different on computer visions or maybe on natural language processing as well. So why am I even talking about these things, right? So one thing, after going through all the course modules, I'm pretty much sure most of you are really interested to look into the like to work on various things, right? So you are looking into build your career on top of machine learning. You want to get into a data analyst, you want to get into a machine learning engineer roles, you want to get in as a deep learning engineer roles, or whatever your goals are, right? So mostly you might have been looking into so many courses, like so many YouTube videos, and then so many things, right? So so the whole goal is like when it comes to the industry, right? So what people tend to not forget about is, so your industry is not just your course, it's not just about your some materials that they give it to you, or it's beyond your Kaggle, right? So beyond your Kaggle competitions, beyond your course materials, and then everything that you do as part of your course, it's not just that, right? So people, when I speak to people when they want to build some deep learning models or machine learning models, right? So they tend to do so many things with these things, right? So they just tell that you just clean the data, you just get your training data, clean it up, and then like build a model, and then try to deploy it in the systems, and then start working on those things. So unfortunately, that's not the way that works in an industry. So there are so many things beyond that, right? So mostly, people who really want to get into this field, really they need to get their hands dirty on in terms of your software coding fundamentals, your system design fundamentals, and everything, right? So that's very, very important for us. So what I'm going to talk about in this session is you take up your models, your deep learning models, your machine learning models, or anything that you want to take it up, right? So how do you take these models beyond your Kaggle competitions, take these models beyond your whatever the course modules that you might be having, or beyond your Medium blogs, anything that you can talk about, or beyond your YouTube videos, right? So because mostly these YouTube videos, everything, they build a sort of a misconception of how exactly things are working, right? So mostly we'll be talking about those things, so that you could also learn from some of these things, and then apply it, right? So even when you want to attend some interviews, or you might be someone who's trying to get into this field, or you might be someone who's trying to get into an internal transition, or want to switch your jobs into data science. So definitely, right? So if you are someone who's looking into these things, so that will be really helpful for you. Right. So without wasting much of the time, right? So let me just start talking about a topic. So the very first thing that people, when I go ahead and then sit in interviews, and then ask them about, how do you even try to build a machine learning system, right? So people, they talk about what they have been going through in different courses, in different YouTube videos, and different things. But unfortunately, those things do not work, right? So when I talk to people asking about these steps, so what they tell me is, they start off with taking a data set, and then they talk about some EDA processes, and then you talk about feature engineering, you talk about building your models, you talk about reiterating your steps again and again and again. Right, so these are all good. So definitely, so if you ask me, don't we use these things in our industry as well? So my question would be, yeah, my answer would be yes, we do use these things as well. But but it's just a part of it, it's a very small part of it, right? So it is going beyond these steps, right? So you have to think in a more broader perspective, right? So in most of my slides, we are going to talk about that. So to answer the simple question, right? So how do you even start off with how do you approach a machine learning system, right? So I'm not sure how many of you are even aware of these things, right? So the very first thing, whenever you try to take up a problem or anything, right? So first thing, people, what they really do is, they take a data set, and then they do some EDA, and then they do some feature engineering, and then build various random amounts of models, right? So regression, you have your ensemble methods, you have your deep learning methods, your SVM, any model that you can talk about, right? So they just start applying these things in a very random way, right? So but how your thought process should be is, right? Like how do you go ahead and then start off with these things, right? So like before even taking up a data set or before even taking up anything, right? So understand what is the problem that you're trying to solve about, right? So what are we trying to do it, right? So like what is the problem that we are going to solve, and then how is it going to help it for you, right? So like when you talk about your basics, when you talk about anything, right? So those are all already there for you, right? So that's not at all a problem. So when you start off with an like like a machine learning system, so what exactly that you need to do it, right? So the very first step that you should be doing is build a deeper understanding of the problem, right? So understand like after you building this particular system, so how is it going to help you out, right? So is it something that like it can be done without using your machine learning algorithms, or after using your machine learning algorithm, what is going to be the advantage of it, right? So when are you going to use it, how are you going to use it, and then who is going to use your particular models, right? So you should start asking these models. So it's very very important, right? So because it depends on where you are tending to run this particular model, in which system are you going to run it, what problem are you going to solve it, right? So the next thing is that you definitely, like when you talk about your deep learning models, right? So you must be aware of that, right? So your deep learning models are very very computationally intensive algorithms, right? So it requires lots of computational power to do that. So you should understand what is your system requirement, and then when you talk about your system requirement, and then you should again go back and ask about your problem, right? So does this like investing so much in your system, does it even going to bring any benefit for you? So that's very very important for you, right? So now once when you understand some of your problem statements in hand, and then when you understood what are your system requirements are, so the next thing that you should be thinking about is identify your metrics, right? So what kind of metrics that you should be using it for your model, right? So if it's an regression problem, it's an classification problem, it's an unsupervised problem, so what kind of metrics that you can use it over there, right? So your metrics is does not just like limited for your r square, your adjusted r square. There's so much beyond that, right? So you have to come up with your own metrics whenever you try to start building your model. We'll look into that. We'll take an like a very beautiful case study, and then we'll talk about how do we define our own metrics, how do we decide on those things. We'll talk about those things. And then the very next thing that you should think about whenever you're trying to build such systems, right? So you have to envision your complete end to end your system architecture, right? So from starting from the first step, starting to the end step, right? So whenever you're trying to build any deep learning models, right? So your deep learning models, it's not just limited to your train data, your test data and everything. So what is the end goal of building your deep learning model? So the end goal of your deep learning model is going to be, it's going to be used in your real world scenarios, right? So people are going to pass on inputs, and then it's going to get out outputs, right? So how do you go ahead and then deploy your models? How what kind of system do you need? What are all the different steps of like pre-processing that you need to do it? So how do we do that? So how much data is it like tend to come to your system, right? So everything that you need to think about. And then the very next step that you want to talk about is like like come up with a training data generation strategy, right? So when we talk about our deep learning models, some of the very important point that people tend to forget is they forget to like understand like building a model today, and then if you come back after 3 months, or maybe if you come back after 6 months, right? So the model is not going to be as significant as it was today. The reason is what really happens is over time goes up, right? So the model tends to like like you'll be like getting some different inputs, and so many things, right? So that's the reason. So like you need to keep on building your model again and again. And when we talk about deep learning, so deep learning requires lots of data, right? So you can't model, like you can't label it, you can't collect your data manually. So that's going to cost too much for you, too much resources for you, right? So that's not at all going to help you out. Right, so definitely you'll also have to come up with an training data strategy, right? So automatically, like we call it as an data ingestion pipelines, right? So that's very very important for us. So the next thing that comes into your your approach is how do you come up with your feature engineering task, right? So if you talk about any machine learning engineer, machine learning models, or any of the models, right? So the features are the ones that is going to decide what is going to be the the performance of your model, right? So if you have unwanted features in your model, that's not going to bring any value for your model. So definitely feature engineering is very very much required. Even you might talk when we are working with deep learning models, so why do we even need to worry about features? So that's what exactly is deep learning about, right? So even if you have to unwanted features even in your deep learning model, so again it's going to increase your computational costs, right? So your complexity of your models is going to increase, and then there are lots of things that is going to increase in those terms, right? So feature engineering is definitely required for you. And then finally comes up with your selecting your best suited ml model, right? So when it comes to your selecting your ml models, right? So there are a lot of constraints that you need to look into, right? So we'll talk about those things, right? So how do you go ahead and then select your models, and then how do you split different tasks and everything, right? So in the coming slides we'll talk about those things as well, right? So going we'll talk a little bit about after going through some of the general steps that you really need to look into whenever you want to build a model. So let's go ahead and then look into some of the ml architectures, right? So how do you go ahead and then select your ml models based for different scenarios, right? So what is the strategy that you should be using it, right? So mostly, right? So let's take an example, right? So everybody must have been trying to use your Google search engines, right? Okay, so enlarge my screen. Okay, so this is the best I can enlarge, guys. Okay, so let me return to the presentation. Okay, so mostly most of you must have been using your Google search engines, right? So Google search or Bing search or anything, right? So have you ever thought of, or have you ever given a thought might Google might be using deep learning within their engines, or any search engine that you talk about, right? So they do use deep learning within their profile. So how do they go ahead and then build such a system, right? So they might be getting lots and lots of requests for them. So how exactly are they doing it, right? So it's not just your training data that's going over there, right? So if you want to give an input to your model, right? So there are so many various pre-processing steps that you need to do it. For example, let's take an example that there is an user who's wanting to search for some some local restaurants, right? So he wants to eat an an Italian food. So all of a sudden it was a weekend, and then he thought of having some Italian foods. So how would you do that? Right, so how would you go ahead and then with certain constraints, how would you go ahead and then build a search ranking system, right? So for example, the processing steps would look something the person who would go ahead to the search result, the search box, and then try to search for Italian restaurants, right? So, and again, if you are talking about people, right? So mostly we don't remember most of the the spellings for us, so we have to take care of that. So the system, somebody might type in Italian ITLIAN, or some other spellings that you can think of. And then how does even Google understand the whole thing, right? So what really that happens within the scenes is, so they have some pre-processing steps, right? So for example, you have Italian restaurant. The first thing would be to correct your particular spelling, right? So that's very very important, because if you do not correct your spelling, right, so whatever the features that you are going to create apart after that, so that's going to be affected a lot, right? So you have to first you have to fix your spelling. So once you have fixed your spelling, next is you need to understand what exactly is your query about, right? So now somebody talks about just searches for an Italian restaurant. So what is his intent, right? So is he searching for in a different city? Is he searching for in a local city or anything, right? So you have to understand the intent of that. Of course, so there are various models for that, and then so many stuff there are, right? So but I'm just talking about the architecture in general. So how do you go ahead and then build those kind of systems, right? So once you have the intent of what exactly that you are looking out for, and then you go ahead and then put a document selection, right? Because if you search for an Italian restaurant, and let's take an example of Bangalore, right? So in Bangalore, you might be having so many Italian restaurants, or in our area, you might be having so many local restaurants, right? So those are all like stored as documents in your NoSQL databases, right? So now you had to go ahead and then select those documents. So once when you have selected those documents, and then go ahead and then give it to your ranker system. So ranker system is where your machine learning algorithm goes ahead and then sits over there. Right. So we'll talk about how do you go ahead and then build your ranker system. We'll take an example of our tweet feed, and then we'll talk about those things, right? So and then your ranker system is going to rank your results, right? So which are the restaurants that it should show it, and then stuff like that, right? So we'll talk about each of these things in a little bit. So but by now you must have got an idea about whenever you try to build any system, right? So you have to think from end to end, right? So it's not just about building your model in your Kaggle notebook, or in your a Google Colab notebook, or in your Jupyter notebook, right? So you'll have to think about the complete end-to-end system, right? So that's what would bring a lot of value for you, right? So that's something that you definitely need to take care of, right? So, and what is the next biggest problem that you have it whenever you try to work with systems like deep learning and machine learning algorithms, right? So just think about I was in this particular example, I was talking about the search results, right? So you want to build an deep learning model, so that is going to give you some search results, right? So based on your query parameters, so you are going to get some search results. So whenever you try to build a deep learning system, right? So you'll also have to worry about the scale in which it's going to work about, right? So what is that scale that we are talking about, right? So now let's say, for example, in India, how many people might be using the Google search, right? So on a daily basis, or let's say I'll leave it even on a daily basis. Just think about how many users might be using the Google search engine on a per minute, or maybe per second, or something like that, right? So it must be like a huge amount, right? And also, right, so that's one thing over there. So the number of requests that comes into the system, so that's one thing over there. So what is the next thing, right? So when you talk about restaurants, right? So restaurants can be of various ways, right? So it can be like people might search for South Indian restaurants, they might search for North Indian restaurants, they might search for continental dishes, or Italian dishes, they might be searching for like anything, right? So there are various kinds of restaurants that might be available over there, your Chinese one, there are so many things over there. And then just think about given the the diversity of your search results, right? So there are so many various ways that a person can put in the input data to your model, right? So like how complexly that you can build your model, right? So as and when you are going to increase your training data more and more and more and more, and then the complexity of your model is going to increase a lot, and that's going to bring you lots and lots of issues, right? So talk about vanishing gradients, talk about exploding gradients, anything, right? So it's going to increase in a lot way of manner. So you need to come up with some architecture to control these things. For this, let's take an example. You might be whenever you go to various websites, right? So what really happens in these various websites, you might be looking at different ads that pops up, right? So you open your Facebook, there are different ads that pops up. You open any website, right? So you can see there are so many various ads that have been popping up. And one of the major application where you really want to apply deep learning would be your to show relevant ads to the users. Because why should you even worry about relevant ads, right? So if you do not show relevant ads to a user, right, so the people might not click on that ad itself, right? So that's a loss of business. Of course, for the website owner, it does not mean anything, but for the the person who's running those ads, definitely he's going to be affected the more, right? Of course, even the website owner might lose a small amount of bugs, right? So he might not be able to earn something from his ads or something like that. So it's a loss for everybody, right? So if the whichever Google AdSense. Talk about Google AdSense. Now, if Google AdSense does not show you whichever the page that you visit over there, if Google Ads does not show you relevant ads, so what is going to happen? People are not going to click on those ads. And then if those ads do not make sense, or whoever is hosting in that ads, if that does not make sense, Google does not make any money. So if Google does not make any money, whoever is the website owner or wherever this ad stops over there, so even they don't make any money, right? So it's very, very important for them to show relevant ads. And then when you talk about relevant ads, just think about the diversity of ads that might be there, right? So there are so huge vector of ads that you might think about, right? So you have your product based ads, your cosmetic ads, like it might be on ebooks, it can be on trips, it can be anything, right? So just think about so many. The data is very, 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 very huge, right? So and then think about when you have to build a model to accommodate all of these things. So that's going to be very, very difficult for us. So in the industry, a very popular technique that we use it, so that we call it as a funnel technique, right? It's a very, very simple. You might have been seeing this using funnel in different places, right? So that's the same technique that we use it over here as well, right? So we build machine learning models for each and every stage, right? So for a stage 1, we build a machine learning model or a deep learning model. For stage 2, we build a different machine learning model and a deep learning model. For stage 3, we build a different machine learning model or a deep learning model, right? So we'll talk about these things, right? So we'll take a beautiful case study, and then we'll see how this funnel technique is being used, right? So that's something we'll look into the coming slides, right? So one thing that you really need to understand, right? So like a majority of the people who are working on machine learning, right? So it has nothing to do with building your models. This is, I'm pretty much sure, serious about this one, right? So mostly people think that when they go ahead and sit into the industry, so they think that the first from day one they are going to sit, and then they are going to get some trained data, they are going to do some data analysis, and then they are going to build some beautiful looking models. But unfortunately, it never happens, at least within your case of deep learning, right? So it's very, very, very unlikely for you to build your model from scratch. So most of the time people would be using something called as your transfer learning, right? So just a quick refresher about what is transfer learning. So I'm just talking about the basics, I'm not going too deep into any of the topics, guys, right? So when you talk about transfer learning, right, let's assume, right? So you want to build an beautiful a model that is going to identify faces of people. Now take an example of your say for example, like government wants to understand, instead of taking your thumbprints, so they want to take your particular picture and then try to match it up with their database records, and then get the Aadhaar number for you, right? So do you think in that such a scenario, people are going to use whatever the training data that they might be having? So it is going to take a huge lot of time for them to build a deep learning model, something similar to that. So most probably, if you could look at, right, so there are these big companies who are really generous enough to open source some of their models, right? So you take about Google, you take about Microsoft, you take about Amazon, you take about Facebook. So there are so many models that have been open source by these companies. And most of the time, because it takes a hell lot of time to train your deep learning models, right? So there was a case back when with you have your GPT series of models, right? So your GPT-2 model, you might be looking into so many blog posts about that, how much dollars have they spent to train that particular data, and then how many model, and then how did they get the data and everything, right? So the cost is really, really huge, right? So and then companies are still at least you can say only 15 to 10% of the companies are the ones who have really started using this deep learning concepts, and most of the companies are staying away from deep learning. The reason is there is a lot of cost that's involved over there, right? So they have to look into so many things and then so many stuff over there. So that's one of the reasons why not all the companies are using deep learning. But mostly if the companies, you look at your startups and everything, you might see like deep learning is pretty much common between them. So what they use is they use something called as your transfer learning, right? So very, very important concept. So if you really want to get into your deep learning and other thing, right, so there is something on a website called as an Hugging Face, right? So you can easily search for that in Google, and then you can see there are so many trained models over there, right? So that's one of the biggest source. And then of course there you have your TensorFlow, they have open source so many models over there. You have so many other companies as well, right? So who have open source their models. So the reason why people want to stick to transfer learning is the first reason is they have limited training resources. Because when you want to train really efficient deep learning models, right? So I'm not just talking about a small like a house pricing data set or something like that, right? So when you want to build a deep learning model, right? So the amount of data that should be used should be really huge in nature for that to work really well. Right, so and then if you want to train such a model, right, so you need lot of computational resources, and then it's not at all cheap, right? So think about, like you go to Google Cloud and then try to look at some of the GPU machines you want to hire up to, right? So you will see that the costs are very high over there, right? So and then think about, you want to train 1 billion rows of data, right? So it's going to take a lot of computational resources, right? So that's the reason usually people go for transfer learning. So with transfer learning you have like a limited resources training, so you want to go with the transfer learning, and then mostly common sub problems, right? So if you talk about any problem that might be coming up, so back then if you might have been using your Google's Gmail, right? So Google Gmail has something called as Smart Compose when you're trying to write in your mail. Right, so and then most of the companies are trying to use that, including Cerner as well. So where like we are trying to build a system similar to Smart Compose. Now, if I have to build a system like Smart Compose and something like that, right? So I definitely we would be using the transfer learning over there. Right, so maybe we can use our OpenGPT-2 or your BERT models, which Google has been using, right? So and then stuff like that, right? So that's how people look into. And the next thing is you definitely have limited amount of data, right? So just think about the efforts when you have to have some 1 billion rows of data, right? So what would be the effort to collect such huge data, right? So that's going to be very difficult for you, right? So but rather if you have your transfer learning, you would not need that much of a great amount of data. So you can use build your deep learning models with limited amount of data as well. And definitely the growth in the ML community, right? So there are so many having your particular model, they talk about different strategies, and then they talk about how to improve these models, and then all of the community gets together and then they start building up those things, right? So that's the advantages that you would be getting with transfer learning. So the takeaway from this particular thing is, whenever it comes to industry, right, so people don't build the deep learning models from scratch. So they usually use something called as your transfer learning. So that's the takeaway over here. Right, so we'll take a beautiful case study, and then we'll try to architect a particular deep learning system from end to end, right? So I'm pretty much sure most of you might be looking forward for that one, right? So we talked about so many things, how do you approach a problem, how do you, what are all the different strategies that we can apply with respect to deep learning, what are the when people have to choose the models, what are all the different strategies that they might use it, and then how do they generate the training sources and everything, right? So of course when I talk about these things, it would all be going above your head right now. But if you take a beautiful example, and then if I talk about the same topics again and then try to relate it, so that might make very much a sense to you. So the problem in hand that we are having is, so most of you, I'm pretty much sure you must have been aware of Twitter, right? So Twitter users, whenever you try to open your Twitter, so you might be seeing so many tweets that have been suggested to you, right? So from your connections, from your friends, from your outside of your connections, whichever the tweets that your friends have liked about, and then everything, right? So so that's something that we call it as your Twitter feed, right? So now the task over here is, so you have to you have to build a system that is going to predict the Twitter feeds for you, right? So what is the goal, right? So why should you even build about build this particular Twitter feed, right? So if you don't see relevant Twitter feed in your Twitter tweets in your system, right? So whenever you try to open your Twitter, so the users, right, so they are not going to stay longer in your platform, right? So it won't be much of an engaging experience for them. So if it is not relevant enough for them, so they might just go off from your platform, right? So they might start using your Facebook, your LinkedIn, and everything. So if people move away from a platform, right, so that's going to be a huge business loss for them, right? So that's the reason you want to build a Twitter feed system, so that is going to engage the users, right? So show them what exactly they want to look at. So how does Twitter does it, or how do you build a system something similar to that, right? So let's take an example, right? So let's say that you are the user A, and you might be having some n number of connections, right? So let's say, for example, user B, user C, user D, right? So you might be connected to so many users. So whenever you try to open your Twitter feed, so you might be looking at some of the your tweets from your connections. So there are various social graph that we can talk about, right? So your first connection, your second connection, your third connection, fourth connection. So there are various things, but we will not talk about very deep into those architectures, right? So it's something very similar to that what you would see in your LinkedIn as well, right? So if you have been looking into LinkedIn, right, so you might see like number popping up beside your profiles, right? So first connection, your second connection. First connection is something that you are directly connected to that person. Second connection is something someone who is connected to that person, and third connection is something mostly you don't know that person, right? So some of your second connection persons might have might be connected to that person, and then something similar to those things. So that's how the social graph, but we'll not talk about those things in this over here, right? So let's say, for example, we have an user A, and then this particular user is connected to has some direct connections for different users. And then if we want to show some Twitter feed to this particular user, so how would we do that, right? So our goal is to make sure that our user A does not leave our system, right? So that's our goal. That's how we should be building our system. See, we are talking about a business problem, right? So before even going ahead and then trying to build a machine learning algorithm, we want to talk about what exactly is the business problem over here. So after solving this business problem, what is the advantage that we are going to get? Our platform is going to be famous. We are going to earn lots of revenue. So that's how you think about the business over here, right? So you want to keep your users engaged in your particular platform. So that's your goal over here. Right. So for that, how Twitter used to do it before even having your machine learning algorithms. Right. So they used to use something called as your reverse chronological order. Let's say, for example, you logged out of your Twitter at 5 p.m. today, and then you log in back at 6 p.m. on the same day, right? So how exactly does Twitter goes and then shows you the chronological order? Let's say, for example, during this process, there was user B, user C, user D have posted some recent tweets. So the first the recentest tweet is the one that the user A is going to look at, and then the next based on whatever the recency, right? So it is going to be on that order of what Twitter used to show the feeds to the user. So now what is the problem over here? So the problem is not all the tweets that your connections post, right? So it might be relevant to you. You might not even be interested in some of those tweets. So whatever the relevant tweet that you might be interested to look at, right? So that might be very down over there. Right. So, and if you don't look at interesting tweets, you might lose interest in the platform itself, right? So you might not even stay in the platform for let's say, for example, say, for example, 1 minute or 2 minutes or something like that, and then you might move away from the platform and then start using Facebook or any other platform that you can think about, right? So the goal over here is to retain the customers, to engage the users in the platform at all, right? So how do we do that? So the way to do that would be to show those users the relevant tweets for them, right? So which they are really interested in. Right. So how do you understand, how do you come up with those interesting tweets, or how do you know that this particular person is even interested in that particular tweet? And then how do we use a machine learning model to predict something this one, right? So is what we'll talk about in our coming slides. Right. So you understood the problem, right? So the problem is to show an user the relevant tweets, so that he is he stays behind in the system for a long time. So that's the whole goal of our building a Twitter system. Right, so let's look at, right. So and then when we talk about Twitter, everybody knows Twitter is a very very famous a platform. We need to, like, whenever we try to build any systems, I was talking about in the starting slides, you need to scale your system as well. You need to understand in what kind of system are you going to use your deep learning model. Right, so for example, let's have some assumptions over here. So let's consider that at a time, right, so at the time when we are trying to build this particular model, so we are going to have some 500 million daily active users. So that's the first thing that you need to talk about. And on an average, right, so let's say for example, user A has some 100 connected users, user B has 100 connected users. On an average, we are just making some assumptions over there, so that we can build a very intuitive model considering these things. And then definitely, and we'll have one more assumption saying that a user fetches 10 times the feed, right. So for example, the user comes back to the particular system on an average on 10 times. So just think, when there are 500 million daily active users, and then each of these 500 million daily active users, they are going to fetch their particular feeds for 10 times daily, right. So they are going to log in 10 times, right. So then just think about, whatever the ranking model that we are going to build, right. So it's going to get 5 billion calls per day. So do you look at the way how the scale has been grown up over here? Right, so if you don't consider these constraints, right, so whatever the model that you are going to build, it's going to be just useless. They're just going to throw it off, right. So that's how things work in the industry, right. So you have to definitely think about the architecture. You should understand whatever the model that you're trying to build, so where exactly is my model even being going to be used upon, right. So we'll take this constraint now. So you want to build a Twitter feed system, so where there are 500 million active users, and then who log in at least 10 times a day, and then which means there are at least 5 billion calls per day for your particular ranking model. So you have to build such a a model. And then the whole goal is you should not leave the users go out of the your platform. So that's very very important for you, right. So that's the problem statement, right. So build after going through various steps, now you build your problem statement. What is my problem statement? My problem statement is, given a list of tweets, you have to train an ML model that predicts the probability of engagement of tweets and orders them based on that score. Right, so very 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 simple problem statement. You want to build a tweet system that is going to show you the relevant tweets whenever you try to log into your Twitter. So that's your relevancy, right. So going the next thing, when you decide upon your business problem, what I was talking about is come up with your metrics. I was thinking talking about, when you talk about your metrics, it's not just about your adjusted R square. It's not about just your your cross entropy or binary entropy and then stuff like that, right. So there are so many. You don't just talk about precision, you don't just talk about recall, you don't just talk about F1 score. There are so many other things that you should be looking at, right. So each of the problem that you're talking about, right, so each one of them, they are going to have their own metrics. For example, right, so now how do you need to come up with metrics for each of the positive user actions that they do, right. So how much time spent viewing a tweet, liking a tweet, retweeting it, commenting on a tweet. So negative user actions, you need to handle it, right. So hiding a tweet, reporting tweets as inappropriate. So you need to have metrics for each of these things, right. So so that's how you should be building a model, right. So you should decide on what are all the different metrics that you should be looking at. So that's very very important for you, right. So how all of these things are going to land up, right, in a you'll be having some in Twitter, you'll be having something called as your feed analyst, right. So the moment when you try to get some Twitter feeds, so it is going to generate a lot of value for them, right. So it decides on the revenue that Twitter is going to get, and then so many other things, right. So what are all the number of likes that a tweet has got, what are all the number of comments that a tweet has got. These are all your positive factors. What are all your negative factors? So negative factors are nothing like how many people are they just hit the tweet. so they just flagged it as inappropriate. So those are all your negative traits, which means these kind of tweets should not be shown to an user with relevant interest. And positive like traits are the ones that you should be showing it to the users with the similar features that they might be having. And another important thing that you should be thinking about is, so how much time a particular user, so given these positive attributes, so how much time a user is engaging in this platform. So let's say, for example, we built a beautiful model, and then we showed some very relevant tweets for them. And then even after showing so many things, and then user doesn't stay in that platform for let's say even not even for 1 minute, which means our model is not going doing good. So people are not interested about our tweets. So that's how we should be drawing conclusions on, right? So it's going to affect the the revenue of the particular platform. So that's how you should be looking at these things, right? So now, how would you build a system something similar to this one? So definitely, whenever a user tries to log into a system, so he's going to after looking at the relevant tweets, whatever the tweets that he is going to have. So he's going to look into all of those tweets. He's going to select some of the tweets, and then he'll be these tweets would be again written to your ranker system. And the ranker system again automatically it goes ahead and then generates its training data, and then the training happens again, and then it would be fed to the ranker. Right, so again your ranker would be it would be retrained on this particular data. Right, so why should we even build a pipeline something similar to this one? Just imagine, right? So there are per day, you have 500 million users, and then 500 million users, they are going to generate a huge amount of data. And then every day, if you try to go ahead and then start building collecting this data manually and then trying to retrain your model, that's going to take lot of resources, and then it's all a waste of time. And then you can say that whatever the model that you have built, so that's not going to be useful at all. So you have to build a proper architecture for this one, right? So where your model would be learned by itself, right? So that's the whole goal of it, right? So maybe I'll just speed up a little. I think we have very less time. If you want, I was talking about when you want to build a ranker system, right? So it's not just going to be one single model, right? So there might be multiple models, right? So let's say, for example, there would be an one model that would be estimating the time spent. There would be one model that would be predicting the probability of a comment. Because if people show some tweet to a person, right? So if that particular model, if that particular person does not comment on that tweet, which means he's not engaging enough in the with the system. If it's not engaging enough with the system, he is most likely to leave the system, right? So we want to show him tweets where he is most likely to add a comment, right? So and then we want to build a model who's going to who the probability is going to be of a retweet, right? So is the user going to retweet a particular tweet, right? So because he thinks that that particular tweet is really interesting for him, and then he wants other of his friends as well to look at that. And then there'll be a model that is going to predict the probability of a like, right? So is the person, is he going to like that particular tweet or not? So the same thing happens in your LinkedIn, everything, right? So just to quickly experiment this thing, what you can do is go to LinkedIn, search for certain keywords in that, and then you like all the posts. You just log out of that particular tab and then come back to LinkedIn, and then see, you will see only those whatever the the posts that you like. You will see only those relevant ones, right? So that's how these things play behind the scenes. And then there'll be a model that will be predicting the negative traits as well are important, right? So what is the probability that a person is not going to who's going to hide a tweet? And then what is the probability that a person who's going to report a particular tweet, right? So there are going to be different models in your ranker system, right? So that's how your ranker system would be built. So what did we get from these things? So it's not just going to be one single model for you, right? So it's going to be an a stream of models, right? So there are going to be multiple models that you should be looking at, right? So that's how you should be building your model. So going further, right? So talking about the feature engineering part. So I was talking about feature engineering is at the core of everything, right? So you have to build features that really make sense, whether you are working on an a machine learning model or you are working on a deep learning model. Feature engineering is at the core of everything, right? So what are all the kind of features that you can think of, right? So the features can be anything, right? So it can be on the like the features can be based on your historical interactions, similarity based features, again you can be have influence based features. Influence based features is you might be following some really good cricketers or film stars or anything that you can think about. And then you can talk about your author's tweets, right? So how many tweets have you interacted with? And then again coming up with content based features, right? So like are you like, since you are all in like a data science enthusiast, so content based features, right? So showing content based on data science. And then how out of these content based features, how interactive are you with those things? And then again comes with the features is the what are the days of your week, right? So on what day what do you tweet, the time of the day, and approach if there is an holiday, how would you interact at that point of time? And then so many things that you should be looking at for your features, right? So that's how you should think in all the ways, right? So that is going to really make sense, right? So of course if you think a little bit more about each of the features that I've talked about over here, so definitely it's all going to make sense, right? So you have to think about these things. It's all about thinking what kind of features that I can create. So whenever people approach any training data set, right? So what really happens is people, they just limit the knowledge with that particular training set. They don't think beyond that. You should come up with your own features, try to combine from 2 to 3 features, or then try to come up with new features which are really going to make sense when you're trying to build your model, right? So that's very very important for you. And then when you come to your with respect to your the very next biggest problem that you might be having is generating your training data, right? So talking about, and I was talking about models, right? So whatever the model that you built today with respect to at least Twitter or systems like this, right? So it might become very irrelevant for the next day, or maybe like after 1 week, or maybe after 1 month, or maybe after 2 months, right? So in that case you have to continuously retrain your model, right? So you have to make your model as accurate as possible. And then you have to come up with an architecture for training data generation as well, right? So it has to be everything automated in nature, right? So as automated as possible. And then finally comes to our model building architectures, right? So how do you given all of these constraints, how do you go ahead and then build a model, right? So as I was talking in my previous slides, right? So either you can have a single model, so that is going to do everything for you, right? So all of the approaches that we talked about, right? So you for the retweeting model, everything, right? So you can have just one model, or you can have multiple models. That completely depends on you. And then when we talk about whenever we talk about such huge data, right? So definitely there has to be a neural network that should be involved. So in reality what really happens, I was talking about the funnel technique. Maybe you guys might have observed that or not, right? So I was talking about the funnel technique. So let's say for example there are initially there would be 100k tweet selected, and then to reduce to 500 most engaging tweets, you can use a very weak model which is going to be way very very faster, right? So something like your logistic regression. And then once when you are done with that, so that logistic regression, and then you can pass it to your neural network, so which is going to be very very accurate, very very complicated in nature. And then you would get your your final tweets, and then you can select your most relevant tweets and then show it to the user. So that's how you can build using an funnel technique that I was talking about. And when it comes to let's say for example you don't want to go into staging or funneling techniques, you can even try to build a deep learning model. So we have something called as multitask deep learning models, right? So you can just Google for that, you'll look at that, right? So we have something called as multitask deep learning models. So you can even try to use that. But again, so to build a multitask deep learning model, so the efforts are going to be really huge in nature, right? So you need lots of data, lots of computational powers, and then everything. So that's one thing that you should be looking at. And one main thing, right? So now we talked about so many tweets, we talked about so many machine learning models, we talked about feature engineering, we talked about so many things. What about the diversity of tweets, right? So you know that, right? So whenever there's a lot of data that is involved, it's very easy for the model to get like a overfitted. Now let's say, for example, if a person just likes a single user's tweets, right? So he might be like liking the particular user's tweets. So does that mean that whatever the model that you are having, it should only show that particular author's tweets, right? So now let's say, for example, you are user A, and then just imagine if your Twitter, like whenever you try to open your Twitter or whenever you try to open your LinkedIn, if it just shows tweets or posts from a single author, you might get bored from the from the platform, and then you might want to leave the platform because you don't see any relevant things that are coming up, even though we had this like a beautiful machine learning algorithm, right? So a beautiful deep learning algorithm, and then still the engagement is getting lost over there. So how do you handle that particular case, right? So for that, you need to start penalizing your model, right? So we should make sure that whatever the models that we are building, right, so they should be diverse enough, right? So for that, you need to understand your business problem, what is going to happen, right? So it's very important for you to to model your to penalize your models. There are two ways to penalize your model. So one is like if your model starts showing lots of just the tweets from an a single author, right? So you penalize your model in that case. And then if your model is showing just content based tweets, right? Just videos or music, right? So again, you penalize your model. So you need to think about these things. So that is how you would be building a system from an end-to-end perspective. I know I've been going through a little bit lots of very huge topics today, but the whole goal to talk about this one is mostly when people want to talk about the basics of deep learning, when people want to talk about the basics of machine learning, right? So they forget what exactly do they need to work upon, right? So industry does not work just on your Kaggle, industry does not work just on your courses. So it's way very beyond that. So that I was in your same situation where I used to go through so many things, go through the course materials and everything, right? So but you should think beyond. So how does the industry think? So that's how you should be building your thought process. So that was my whole goal of talking about all of these very important concepts. So I hope it was useful for you guys. I really would like to talk a little bit more, like, so even if I talk for 1 hour or 2 hours more, it's very less for me, but I think we are running out of time. So
Absolutely.
definitely,
Yeah. Shishant, that was a great session. A lot of people enjoyed it. We have a lot of questions for you now. So,
yeah.
we'll start with the AMA session. For before that, thanks for including a case study. Okay, I didn't know about this, and just including a case study about Twitter. Okay, and that gave a lot of insights to them who are beginners into deep learning. And there are a lot of questions coming up. So I'll just ask you the questions here. So you can see the question.
Oh, sure, sure.
So starting with the first question, it's
So are you posting the question somewhere? Okay.
yeah.
Okay.
The question is, can you suggest some sites to deploy deep learning models?
Suggest some sites to deploy deep learning models. Definitely, it's going to be your AWS, your GCP, Microsoft Azure, your Alibaba Cloud, anything that you can think about. Okay, so how to prepare for data scientist placements in any company as a freshers? Okay, so that was exactly the thing that I was talking about today, Arihan. Right, so whenever you go for any company as a fresher, right? So be it as a fresher, you be it as an like an experienced professional or anything, right? So people, you should go beyond your courses. You should go beyond your like your Medium blog post. You should go beyond your YouTube videos. You should go beyond your Kaggle competitions. You should understand how given a particular model, given a particular scenario, given a particular business model, right? So how do you completely plan it from end to end, starting how do you formulate your business model? How do you choose your models? How do you go ahead and then choose the metrics? How do you go ahead and then deploy your model? What are the strategies for retraining your model? Because a model training is not just an one time effort, it's an multiple time efforts. You need to consider all of these things. And then if you showcase these things to any company, right? So it doesn't matter whichever company that you're trying to approach to. It might be your top product based companies, it might be your like service based companies, anyone, right? So if you showcase this kind of skills, definitely it will be like very very easy for you to crack it.
Absolutely. I hope, Aryan, that answered your question. So let's go to the next question. So we have Jishantu here who have asked three questions. So what
Mhm.
I'll do is I'll one by one flash them so you can
Sure, sure,
accordingly answer them. Okay.
sure, sure, yeah. So how much data is minimum required for building a good deep learning model with good amount of efficiency? So there is no hard and fast rule, Jishantu. Like what should be the minimum? So you talk about you talk to any like experts or anybody, right? So nobody will tell you in terms of just like there should be 1 million rows, there should be 2 million rows, and then stuff like that. So the only answer that I can give you at this time is it should be huge enough, right? So and then again, when you talk about the amount of data, right? So it also depends on the kind of hidden layers that you are going to use, how many layers that you are going to have, how many features that you are going to have, depends on various factors. So all those factors sum up to coming up with your like a deep learning model. So how much data that you might need, like let's say for example you have 100 features, right? So you want to capture all the variability from these 100 features, right? So having just 1 million rows would be very 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 less for that, right? So it depends on the how many features that you are choosing, depends on how much hidden layers that you are having, and then depends on what kind of model that you are trying to build. So is it an like regression kind of system, or is it going to a classification system like that? So what will the best path to learn deep learning for a beginner? So the best path to build your deep learning would be, first understand the basics. I was talking in this particular session about the transfer learning and everything, right? So yes, in industry, nobody builds your complete model end to end unless you are a research machine learning engineer or something like that, who's working on some very top product based companies. In this case, what is the path? First you should understand the basics, right? So for example, you want to build an computer vision algorithm, right? So who is going to predict some images or something like that. First you should understand what exactly does that model does, right? So there are you talk about, I was talking something about your encoder and decoder techniques, like your BERT, you have your OpenGP2, it's a decoder only algorithm, and then everything. So for you to understand these things, first you should understand what is a sequence to sequence model. And then when you want to understand sequence to sequence model, again the basics comes into picture, that's your recurrent neural networks. First make sure that you are very clear on the basics. Now if somebody is talking about, you want to build a deep learning model, so how does a deep learning model even learn, right? So what are all the different problems that you can encounter? Because deep learning is one such fields, right? So which only works on trial and error method. So you take up any advanced techniques, you take up anything, right? So you can see that in all of the techniques, right? So it's all just a trial and error basis. And this thing you can see in this there has been some recent controversies with respect to your open GPT-2 models and GPT-3 models, right? So where they whoever has built that model, right? So they themselves do not know how exactly the model is performing really well for them, right? So it's all about how do they solve those problems, and then that's how you learn it. Understand the basics to the core, right? So if something goes wrong, so how can you say that it has gone wrong? So how do you identify that? For you to identify that, be very good on your basics. So no code artificial intelligence is getting developed. What will be the possibility of creating no code machine learning model and deep learning models in the future? See, no code artificial intelligence is definitely getting developed, but it can never replace humans. You need a lot of intuition. So there was a last slide that I was talking about, right? So we went through developing a model for 500 million users, and then you might have seen, right? So after building so much a complex model, we saw that there was an diversification in our tweets. So how do you understand those diversification? So for those things you definitely need human touch. So artificial intelligence is not something that would be taken over. Of course you have your reinforcement learning and so many other techniques, but you have to have your manual efforts. So can you suggest any beginner level projects in deep learning? You go to a Kaggle competition, and then like there is no like a beginner level projects or anything, right? So the most beginner level project that I can talk about is the house prices prediction, right? So just go to Kaggle, just go to compete, and then just to pick up any of those projects. That should be good. But if you ask me, right, so what would be the right way to learn deep learning or any of these techniques would be to in Kaggle, right? So there's a very beautiful, like like a feature that they have added. Right, so you can look at all the person's code over there, right? So most of the person, they might be like contributing, like like they might be like a Kaggle grandmasters in like notebooks and then stuff like that, because Kaggle wants to build that particular thing. If you are working as a software engineer, right? So one thing that you can say is, if you want to be a really good software engineer, you should know how to read others code. It's not about how well you can code, it's not about other things. You should know how to read others code. So in this case, I would say the similar way, you go ahead and to Kaggle competitions, pick up some most voted Kaggle notebooks or most voted any of those things, and then start going through their approaches. Don't try to do it yourself. Go through line by line in each of these Kaggle notebooks, and then try to copy, try to type it. When you try to type it in your system, that's where your brain will get, like it's your brain is like a deep learning model. Try to type in again and again, your brain learns from those things. And then from various Kaggle notebooks, you'll learn so many concepts, and then finally you take up any problem statement and then apply it. So that's the best way to learn, whether you are a fresher, whether you are a working professional, or whether you have spent like 15 years as a data scientist, right? So that's how people learn it. So thank you,
Wonderful.
clear explanation and answering my question. A special thank you, David. Yeah, thank you guys. Thank you guys.
Yeah, so Sheshanth, it was an amazing session to be honest, and we at DevIncept want to thank you. So here we end with all the questions. Okay, so we have no questions. So there were some very good questions which came up, and you also patiently answered it very correctly, and also guided our audience towards the path they need to take, the correct path, the right path they need to take towards they making their career in deep learning. And I hope you also enjoyed giving this slight talk on a weekend about your most favorite topic, which you are very passionate about. So, like, how was the entire experience for you? Did you enjoy your?
Yes, definitely. I always enjoy teaching to others, because I've seen that, like I have struggled a lot in this particular field, right? So, starting off my journey as an VLSI engineer, and then I started working on embedded systems, and then I started off working on some, like Microsoft Foundation classes, and then I've seen my journey, like how much I have struggled. So I wanted to, like share my knowledge with everyone, so that that becomes helpful for them as well, right? So that they can get an perfect path, right? So when I was trying to attend some of the interviews with deep learning and machine learning, right? So I used to look at these trends, right? So I used to explain them the same things that I was talking about today, right? So like taking and cleaning up the data set and then building a model. So that used to be my like answers for them. So then I understood, like most of these interviews were, like I used to fail a lot in these things. So then I understood it's not about these things. So when you work on an like a machine learning or a deep learning like a system, right? So the system design is something that's very, very important for them. So how do you go ahead and then handle these things is what is very, very important for them. So that's how it is for me. So I definitely
Absolutely.
enjoyed talking about these things and then teaching people. So that's I would like to thank you for providing this opportunity, Omkar.
It's a pleasure to have you. It's an honor to have you. Have a person like you with so like you have so good grounding about the topic. It's what I feel, Shishant. Like deep learning, right from scratch, anybody I think wouldn't teach so well, because you have taught us so well what is deep learning. Because I also didn't know about it. I was also curious to know what it is, like what is deep learning and how can we apply it. Okay, and applying it the right way. Oh, okay. So this session was a complete tour on, and a complete guide towards starting your career in deep learning. And also you explained a lot. You took case studies and you had some actual, you picked some actual metrics, and you were actually talking about the real world scenario. So in all, it was a complete learning experience for all of us who is attending this weekend sessions. And we at DevIncept want to personally thank you for your time, for your knowledge, and also for making it here to a weekend and taking up this session for our audience who wants to become something in life. Our audience are very energetic. They want to become something in life. And your session whatever you have delivered here. It's an amazing session, fantastic session which you did here, and it would definitely help a lot of other people, even though the people who are watching the session which is going to be posted on the channel, okay, not a live session. And all the questions whomsoever have asked, thank you so much for asking. I hope all your questions were cleared. Also, do check the like the certificate form. I'm just like shared the form. So if anyone has not like filled it, just fill it. Okay, it's in the description. And all the social links of Sheshanth, like his LinkedIn profile link, is there in the description box. So after this session, if you have any doubts which you have in mind, you can feel free to reach out to him. Is very good person to talk to, and he'll definitely answer all your questions on LinkedIn. So make sure you hit up Sheshanth on LinkedIn, connect with him, like be a part of his journey, work on some projects. Like he'll guide you some good projects to work on. So he's a great mentor, which I feel, and he'll definitely guide you the right path. Okay, because Sheshanth has faced a lot of challenges, and he is here because of the hard work, the determination, and whatever things that like he has worked on himself. And that's the reason why he's actively sharing his knowledge. He's giving back to the community now. So make sure you reach out to him. And also in the description, you will find all our links. Social links are LinkedIn. We just hit 6.5K on LinkedIn. Thank you so much for all the love and support. And we'll keep growing. We'll keep delivering such good sessions. And also giving you an update. There is one more session there. It's going to be at 6 p.m. And make sure it's going to be on game development. And it's going to be delivered by Altaf sir. So he's working as an engineering management in game development at Jungly Games. Okay, so it's going to be very like enjoyable as well. You'll learn a lot of new things, and he's also having like Sheshanth. He has a lot of work experience in the industry. So we are inviting industry experts here because we want you to become an industry expert one day and do a session with us. So that's the reason why we are like bringing up such people, so you can get that inspiration, motivation, and also learn something. Okay, so thank you all for joining. I hope you enjoyed it. And Sheshanth, any last words you want to say before we go to the upcoming generation who are in like going into deep learning, like who are going, so a kind of a motivation before we end this session?
So only one thing that I would like to say is don't give up, guys. Just try to learn these things, and then whenever you go to interviews or when it's not just about interviews, right? So learning about anything, it's just not about interviews. So interviews are there to look at are you able to work on that or not. So if you are able to do those things, I don't think you have to even worry about interviews. And then definitely, as like Omkar mentioned, you're always free to reach out to me. And then all the very best for your next journey, guys. Thank you all.
Great, great. And all the very best, Sheshanth, for your journey as well, for whatever path you take ahead in life. You will definitely be successful. Okay. And you'll do wonders in life. Okay. And all the very best from the entire DevIncept team to you. And thank you so much for your participation in this
Thank
session.
you.
So that's it for today, guys. I hope you enjoyed it. And we are ending this session now. We don't want to take more time of yours. We'll catch up today 6 p.m. with Altaf sir. Do join, okay, to learn something, with the curiosity to learn something and upskill yourself. And let's meet at 6 p.m. Bye, guys.